So the colloids, it means that it is the glue-like substance. And there are substances called crystalloids and colloids. So the finely divided particles of any substance with a diameter lying within 10 to 2000 angstrom unit range dispersed in any medium is called a colloidal system. This is the definition for a colloidal system. Actually, colloidal system is a binary system which contains two components, something like a solution. Solution contains two components, namely the solvent and the solute. Which is more in composition is a solvent and which is less is a solute. Similarly, colloid is also containing two components. One is called dispersion medium, that is the something like the solvent of the solution, and the other one is called dispersed phase, which is something similar to the solute of the solution. And these two components are also called continuous phase and a discontinuous phase. Suppose if you take the dispersion medium, it is always continuous. See, water is one of the dispersion media and which is continuous. Whereas the dispersed phase is something like particles dispersed in the medium, hence they form a discontinuous phase. So in general, colloidal system is a two-phase system, but the only difference between the solution and the colloidal system is comparatively a little bigger particle size. Say for example, you can see I have noted down many types of colloids. The first one, the dispersion medium is gas. The dispersed phase is liquid. That is a liquid dispersed in gas. Example, cloud, mist, fog. So cloud, you can see the cloud is floating in the sky. Actually, what the cloud contains is the liquid drops dispersed in air. The liquid drops which are dispersed in air can hang on the sky because of its density, less density. But during raining, what happens? The liquid particles which are existing far away will condense and will form a bigger droplet. That big droplet cannot be held there because of its mass, and it will come down as the rain. So it all because of the size of the dispersed phase. If it is much smaller than this, it is a solution. If it is bigger than this, then it is called a suspension. A colloid becoming suspension is raining. And in the second case, the dispersion medium is gas, dispersed phase is a solid. Say for example, smoke and volcanic dust. Nowadays, the bore wells are being made all around our places. You can see. Actually, the dust particles coming out as a smoke is solid dispersed in gas. It is the dust particles dispersed in gas. Suppose if you go to the cinema theater and see the light coming from the back, you can see the smoke. What you are seeing is the dispersion of the solid carbon particles in gas, which is the smoke, which is a colloid. And the another one, a gas dispersed in liquid. Here the liquid is the dispersion medium and the gas is the dispersed phase. Example, foam, white cream. So they are the examples. Foam, something like the soap foam. What is there? the gas is dispersed in liquid. Suppose if you take a carbonated drink, some Pepsi or Coca-Cola or anything, it is a solution where gas is dissolved in liquid. The particle size is very small, it is solution. But here foam is a colloid. The foam, the gas particles are comparatively bigger and they fall, the size falls in the range of 10 to 2000 angstrom unit. So gas dispersed in liquid is another type of a colloidal system. Sometimes a liquid can be dispersed in another liquid. Example, emulsion. Milk is a colloid. Even you can do this experiment at home. Just put a few drops of water and 1 drop of coconut oil in your hand and rub. You will get an emulsion, a white paste-like thing, which is the coconut oil dispersed in water. It is an emulsion. It is also a colloid. Milk is a colloid where water is the medium and all other protein and other substances are the liquid dispersed phase. Sometimes solids may be dispersed in liquid also. Example, starch, protein. So they are all the substances containing solid dispersed phase in liquid dispersion medium. Sometimes gases can be dispersed in solid. Solid can also act as a dispersion medium. A gas dispersed in solid. This is nothing but the adsorbed gases. Say if you take charcoal as the medium, charcoal is a very good adsorbent and charcoal can absorb gases. When the gases are absorbed on the charcoal, now the charcoal and the gas, they become a colloidal system in which a gas is dispersed in solid. Sometimes liquids are dispersed in solid. Example, jellies, gels, cheese. How many of you have seen jellies and cheese? You might have eaten when you were very small kids. Jellies, gel. Nowadays we are using this, what is that? Sanitizer gels now. They are all liquid substances. They disperse the isopropyl alcohol, hydrogen peroxide, and all these things, they dispersed in a solid paste-like substance so that it can stand in your hand for some more time. Suppose if you take a pure alcohol and just sanitize your hand, it will be immediately evaporated. In order to avoid that, the isopropyl alcohol or ethanol is dispersed in paste-like substance, in solid substance, in gel form. So these gels are also colloids. Sometimes solids may be dispersed in solids also. Example, rock salt. You know what is a rock salt? Actually, it is very good to eat rock salt. Normally for our eating purpose, salt is taken from the seawater, which contains mostly sodium chloride. But we need a little bit of potassium also. At the same time, the potassium should not go excess. So rock salt is the salt taken from the rocks in the fossil sedimentations. You can break the rock where the salts are sedimented for a long time can be taken. Actually, what I believe is the rocky place might have been inside the sea for a very long time, even millions of years before. And now the sea might have become a mountain and the mountains have become a sea. So in such situations, the rocks might have absorbed some salt and salt sediments or scalings may be there, and which are a best example for solids dispersed in solids. And also you can see the colored precious stones. See, sometimes nowadays people are using these granite stones for flooring their houses. That granite stones sometimes they appear green color or black color or pink color. It's all because of the dispersion of certain metal ions, certain colored compounds. See, these colored compounds are also solids, but the stone is also solid. A solid dispersed in another solid is a precious stone. So that is also, even colored glasses you can think of as the colloidal substance. The glasses, normally glasses are molten and the colored pigments are scattered, where the scattered pigments are dispersed phase and the glass is the dispersion medium. So these are all the examples of our solids dispersed in solids. So colloidal system is a two-phase system. One phase is a continuous phase and another phase is a discontinuous phase. And we have seen a variety of the continuous phase and the discontinuous phase. And I have seen all these things. And next, colloids can be divided into two major types. You should watch very closely. One type is called lyophilic, and another type is called hydrophilic. Sorry, lyophobic. You know, philic means loving, phobic means hating. Philo means love. Phobic, phobia, fear, the hate. So in the case of lyophilic, the particle size is large. That is at the lower limit, which means that beyond that it will become a suspension. The highest limit, the lower limit of the particle size, that is larger than that. Whereas lyophobic colloids, the particle size is smaller. In the case of lyophilic, there is a strong interaction between the dispersed particles and the dispersion medium. Whereas here no such strong interaction is found. And it is because of the sparingly soluble substance. And these lyophobic colloids will not become colloids very readily. Whereas these substances, that is lyophilic, they become colloids very readily. Example, proteins. Here, ferric hydroxide. You can see the ferric hydroxide. You can never see an anhydrous ferric hydroxide. Ferric hydroxide is a highly deliquescent, but it will be normally existing in the suspension form. But you have to make it a colloid with a bit of difficulty. And also colloidal gold is also available, which is also a lyophobic gold. The lyophilic colloid is also called a reversible colloid, which means if you take the colloid and evaporate, you will get a residue where the dispersion medium is evaporated and the dispersed phase is settled down. If you then add the liquid, that is the dispersion medium, you can immediately get back the colloid. It is possible in the case of lyophilic. Whereas in the case of lyophobic, they are called irreversible colloids. Once the colloid becomes a residue and the dispersion medium separated, and a recombination of the residue and the dispersion medium to get back the colloid is not at all possible. Now look here, there are a number of properties by which the lyophobic and the lyophilic colloidal substance can be differentiated. The first one, surface tension. In the case of lyophobic colloids, the surface tension is same as that of the liquid, that of the dispersion medium. There is no much difference between the surface tension of the pure dispersion medium and the colloidal substance. But if you take a lyophilic substance, the surface tension is comparatively less. That is, the surface tension of the colloidal substance is less than that of the pure dispersion medium. And if you take the viscosity, the lyophobic substances have same viscosity as that of the medium. But whereas lyophilic substances will have the viscosity higher. That means that the substance become thicker. Viscosity is resistance to flow. The lyophilic substance will show more resistance to flow. They are more viscous. Visibility, lyophobic crystals can be seen through ultra microscope. That is, the dispersed particles can be seen through ultra microscope. Whereas the lyophilic substances, you can never hope to see the dispersed particles. They are not at all visible. So if you take the egg yolk and you want to see the albumin dispersed, it's not possible. And also, when you apply an electric field, how the dispersed particles migrate. The dispersed particles migrate either towards anode or towards the cathode in lyophobic colloids. But in the case of lyophilic, they migrate in both the directions or they will never migrate. And the next one, action of the electrolyte. When you add electrolyte, electrolyte means any substance with charged particles, say sodium chloride or potassium chloride or hydrochloric acid or anything which contains anions and cations. When you add the electrolytes, strong electrolytes, within the addition of a small quantity of the electrolyte, lyophobic colloids will get coagulated and precipitated. But in the case of lyophilic, a large quantity of the electrolyte is needed for precipitation. See, nowadays, you might have observed this. You take a milk, put 1 teaspoon of salt, that's all. Your milk will get coagulated and precipitated. The water will be separated and all the protein part and other things will be separated. This is how actually cheese is being made at home. People used to boil milk and cool down and then add lemon. When lemon contains electrolytes, when lemon is added, you can see the precipitation of the milky substances and then the water will come out and all that is settled down can be scrapped off, and which when they are compressed, you are forming the cheese, which can be used to prepare some paneer butter masala or something like that. But what happened one day, I purchased some packet milk and boiled and I went on adding lemon, nothing happened. Which means that the stability of the colloid is much more than the actual stability of the colloid. Which means that the packeted milks are containing some stabilizers or some preservatives which are preventing the normal behavior of the colloid. And the next one, reversibility. So lyophobic substances, they are irreversible. That means you can evaporate, but you cannot get back the colloid. When you take the lyophilic substance, they are reversible. The colloid can be evaporated to residue and dispersion medium. And when you add the residue and the dispersion medium again, you can get back the colloid. And hydration. You know what is hydration? The solvent molecules engulfing the dispersed particles is called solvation. If water is used as the solvent, then it is called the hydration. If ammonia is used as the solvent, it is called ammonation. So if you find the difference between the lyophobic and the lyophilic colloidal substances on the basis of hydration, the lyophobic substances, they are not hydrated, and the lyophilic substances are found to be more hydrated. So these are all the two types of colloidal substances and their differences pertaining to various physical properties of colloids. The next one, the differences among a true solution, colloid, and a suspension. In a true solution, the particle size is almost close to 10 angstrom unit. The colloidal substance, the particle size is 10 to 2000 angstrom unit. In the case of suspension, the particle size is more than 2000 angstrom unit. What is this? Solution. Take a sugar solution, which is an example of solution, true solution. If you take a sugar solution, you can never hope to see the sugar molecules in solution because the sugar units dissolved in water, their dimension is 1 millimicron. But if you take milk, milk is a colloid where the protein and other components of the milk which are dispersed in water, they are of the size 10 angstrom unit to 2000 angstrom unit. And you can see the milk or even you can take the smoke. Smoke is a colloid where the carbon particles are floating in air. These carbon particles, if you see through an ultra microscope, you can see the carbon particles moving and their sizes are in the range 10 angstrom unit to 2000 angstrom unit. In the case of suspension, what is a suspension? You can see some clay dissolved water. You dissolve some clay in water, you can see the clay particles settling down and the water up, or any type of precipitation that you are taking in the laboratory. See the silver nitrate and hydrochloric acid, a curdy white precipitation. It is also a suspension. So these suspended particles are visible in naked eye itself because the suspension particle size is greater than 2000 angstrom unit. If you take a parchment paper or a filter paper, if you put a true solution, that will diffuse readily through the parchment paper. You see, you cannot filter the dissolved sugar using a filter paper. You can understand like this. You can never hope to dissolve salt in water and filter the salt out when you pour the solution through a paper. But whereas a colloidal substance will diffuse slowly, even you cannot think of separating water from the milk. Suppose if a waterman is, if a milkman is adding more water to the milk, you cannot filter the water out. But filtration is possible, which is called ultrafiltration. Even in old literatures, we have seen that the swan is capable of filtering milk from water. It is called ultrafiltration. So this diffuses slowly through the parchment paper. But whereas if you dissolve clay in water and if you pour using a parchment paper, you can see the water alone coming out and the clay particles staying up. So they do not diffuse. That is, the particles do not diffuse. Whereas in the case of colloid, the particles diffuse slowly, but in the case of true solution, the particles readily pass through the parchment paper. And also when you pass light, the salt solution will be as clear as the water itself. So the light path cannot be seen. There is no scattering of the light. But in the case of colloidal substances, a scattering of the light, which means the Tyndall effect, that is the light path is seen. You are not able to see the particle with your naked eyes, but you can see the light getting diffracted, scattered. Suppose if a place is full of smoke and if you just light a torch, not the cell phone torch, a real torch, the beam of light can be seen. Suppose if it is a foggy time where a mist or a fog has fallen, you just light a torch, you can see the path of the light, which is called the Tyndall effect or the scattering of the light by colloidal substances. But in the case of suspensions, the Tyndall effect is not found, but the particles you can see using the light. So the true solutions are also called molecular solutions. The suspensions, they have the tendency to settle down fast. As I've already told you, the clay dissolved in water, if you just set aside the contents without disturbing, you can see the clay particles settling down at a faster rate. But in the case of colloidal system, normally the settling down of the colloidal particles is not at all observed. Can you say that if a milk is set aside for a long time, that the milk particles would settle down from the water medium? It's not at all so. So it is theoretically taken that the settling down is extremely slow, but actually it is not observed. So these are the differences among the true solution, the colloidal substances, and the suspension. Now, the optical properties of colloidal substances. This is another important idea. Actually, it was observed by a scientist called Tyndall in the year 1869. What he has seen, when he passed light through the colloidal substances, he could observe a bright streak of the path of the light, the illuminated path of the light, which means the light particles are scattered by the colloidal particles. And this scattering is because of the difference in the refractive indices of the dispersed phase and the dispersion medium. And this effect is called the Tyndall effect. And the Tyndall effect observed in the hydrophobic colloids are greater than that observed in lyophilic colloids. Actually, this Tyndall effect can be well seen using an ultra microscope. But what is actually seen is not the particles, but the light scattered by the particles. It is the light scattered around the spherical particles they are seen. And what is diagrammatically given here is the setup. To observe the Tyndall effect. You can see an arc lamp. You know what is an arc lamp? It's a carbon arc lamp which can produce a light of composite source with a high intensity, and that light is passed through a convex lens, and the light is then passed through a slit. Slit means a small opening. And then the light is again allowed to pass through another lens. And then there is a cell is found. The cell is containing sol. Sol means some solid dispersed in liquid, colloidal substance. And the entire beaker is kept in darkness, which means you can only see the light passing through the slit and the lens can be seen. All other parts will remain dark. Now the path is viewed through a microscope. This is the setup for observing Tyndall effect. And the next important property of the colloid is the Brownian movement. What is this Brownian movement? This was observed by a scientist called Robert Brown in the year 1827. Actually, he is not a chemist, he was an English botanist. So what he said, he took the pollen grains. The pollen grains are taken from the flowers, and these pollen grains are put in the aqueous medium, and the solution became a colloid. And when this scientist was observing the pollen grains, and he saw the ceaseless and erratic and random motion of the pollen grains. So these particles are moving unceasingly and in an erratic manner and in a random motion. So the Brownian movement is due to the bombardment of colloidal particles by the molecules of a dispersion medium, which are in constant motion, like molecules in a gas. So look here, the energy, the kinetic energy, if you take the kinetic energy, the energy of the medium and the energy of the colloidal particles are always equal. But when you compare the size of the substance, medium is containing molecules, whereas dispersed phase is containing colloidal particles. So molecules are always smaller than the particles. So when you compare the speed, actually the molecules are moving with a faster rate. These molecules hit the colloidal particles, and hence the colloidal particles are moving. And because of the difference in the size, the medium molecules are moving with a high speed, whereas the colloidal particles are moving with a low speed. But this motion is not at all observed in suspensions, because the suspended particles are much bigger, so that they cannot be moved by the bombardment of the small molecules. The small molecules hit the particle, and the particle will never respond to the small hit. This is something like a mosquito hitting a car. What will happen if a mosquito hit a car? Will the car move because of the mosquito hit? No. So this is a visible proof of the random motion of the molecules in a liquid state. See, the molecules are not only moving in the gaseous state, the molecules are also moving in the liquid state. So wherever in any fluid, the molecules are not stationary. So the molecules are moving in the liquid state, the molecules are moving in the gaseous state, but the molecules are stationary only in the solid state. So because of the comparatively bigger size of the particle in suspension, the Brownian movement is not seen in the suspension. Whereas in colloidal substances, the Brownian movement is seen, but at the same time, the molecular motion of the medium is comparatively much faster than that of the colloidal particles. Now, electrical properties.